Episode 6 covers two packages that make Java robust and type-safe, exceptions and generics. We'll write exceptions demo first, the hierarchy, checked versus unchecked, custom exceptions, try with resources, and chaining. Then GenericsDemo, type parameters, bounded types, generic interfaces, methods, and a simple stack. Let's code. Exceptions represent abnormal conditions at runtime. The hierarchy starts at throwable. Below that, error covers JVM catastrophes, never catch those. Exception splits into runtime exception, unchecked, programming bugs, and checked exceptions, conditions callers must handle, verified by the compiler. We begin with a custom checked exception, insufficient funds exception. By extending exception instead of runtime exception, we force the caller to deal with it. We store the requested and available amount so the caller can recover intelligently, not just print a message. We also create a custom unchecked exception invalid age exception, which extends runtime exception, used for immediate programming validation errors. Wallet.withdraw is declared with throws insufficient funds exception. Any method calling this must either catch it or propagate it further. The compiler enforces this, you can't ignore a checked exception. The classic structure, try a risky operation, catch a specific exception type, and run a finally block that always executes, even if an exception is thrown or a return statement is hit. The finally block is for releasing resources, we'll see a better way shortly. When different exceptions can be thrown by the same code, list separate catch blocks, most specific first. Java 7 introduced multi-catch, number format exception class cast exception E, to handle multiple unrelated types in a single block, reducing duplication. We create a wallet with 100, withdraw 60, then try to withdraw $80. The second call throws our custom checked exception. We catch it and use getShortfall to display exactly how much more money would have been needed. A rich exception carries actionable data. Looping over age values, we validate with invalid age exception. Unchecked exceptions don't require explicit handling, but we catch them here to show the message. Use unchecked exceptions for programming errors that callers shouldn't be forced to catch. Java 7's try with resources ensures any AutoCloseable resource is closed automatically, whether the block finishes normally or throws. Our fake database prints open and close messages, after the try block, close, is called reliably, no finally needed. This is mandatory for file handles, sockets, and database connections to prevent resource leaks. When a low-level exception is caught and rethrown as a higher level one, always pass the original as the cause parameter. The stack trace then shows the full chain, the outer exception message, plus the root cause. Without chaining, you lose the origin of the failure. A demonstration of how to programmatically examine the stack trace, getStackTrace, returns an array of stack trace element objects, giving you class name, method name, and line number of each frame. Useful for logging libraries and custom error reporting. Generics allow you to write type-safe, reusable code that works with any type, without sacrificing compile time checks. We'll build a generic box, a pair, a bounded number wrapper, a repository interface, generic methods, and a generic stack. Box is a simple container. When you create box, T becomes string everywhere in that instance, get value, return string, not object. No casting required. The compiler prevents you from putting an integer into a box. A pair of two possibly different types. The swap method returns a new pair with the types flipped, entirely type-safe because the compiler verifies the assignments. By bounding T extends number, we can call methods defined on number, like double value. You can create numberBox or numberBox, but not numberBox, that would be a compile time error. This is the repository pattern. In-memory repository works for any type, strings, users, orders, all with the same storage logic. The find by ID returns optional, carrying the type information so callers get the actual type back, not object. Methods can declare their own type parameters. Max works on any comparable type, returning the greater value. Swap exchanges two positions in an array of any type. mapList transforms a list of t into a list of r using a function. All type checks happen at compile time, no casts. A minimal stack built on linked list. The push/pop/peek operations are type-safe, pushing a string and popping yields a string. No possibility of class cast exception because the compiler ensures the stack holds only the declared type. Now the run method ties everything together. First, 3 generic boxes, box, box, box. Same class, different types, all fully safe at compile time. The output prints each one with its actual value, no casts needed anywhere, then a pair holds a string and a number. Calling swap returns a pair with the types flipped. The compiler verifies the entire swap at compile time, so you can't break it by accident. With numberBox and numberBox, the bounded parameter t extends number lets us call double value, to double the value and check if it's positive. Try creating numberBox and the compiler stops you immediately, that's the bound doing its job. The generic repository stores strings, we save 3 names, list them all, find one by ID, which returns optional, not a raw optional, delete an entry, and list again. The compiler knows the type throughout, no manual casting sneaks in, the generic methods shine next. Max, 7, 3, works on integers, max, apple, zebra, works on strings, the type parameter t extends comparable is resolved automatically at the call site. The swap method exchanges positions in an integer array and prints the result. mapList transforms a list of words into their lengths, via string length, and into uppercase, via string to uppercase, a single reusable function that works for any transformation function you pass. Finally, the GenericStack, we push A, B, C, then peek at the top, and pop all elements until empty. Every pop returns a string with no risk of an accidental integer. The compiler enforces the stack's internal type, so you never get a class cast exception. Next episode we step into functional programming, lambdas, method references, the stream API, and optional. That's where Java's modern expressiveness truly shines. See you in episode 7.